Come back. We are still on mathematical induction, and here is the question. Is 5 raised to the power of 2 minus 6n plus 8 divisible by 9 by mathematical induction if n is a positive integer? So what we are trying to say is that whenever we put any natural number, that is any positive integer inside this expression, is it going to be divisible by 9? So let's check solution. By mathematical induction, the first thing that we need to do is to test for n is equal to 1 is true. So we want to check if we input anywhere we see n, if we input 1 there, is it going to be divisible by 9? So I have 5 raised to power 2 multiplied by 1, that is anywhere I see n, I am putting 1, minus 6 multiplied by 1 plus 8. And that gives me 5 raised to power 2, that is 25. 25 minus 6 multiplied by 1, that is 6, then plus 8. 25 plus 8, that is what? 33. I didn't call that. Minus 6. And that is what? 27. So 33 minus 6 is 27. And 27 is what? Is a multiple of 9. So you can see that this expression is true for when n is equal to 1. So you can go ahead and test for n is equal to 2, n is equal to 3, and so on. So the next thing is to assume n is equal to k is true. So that is, if I pick any natural number, I want to assume that it is true. So anywhere I see n from this expression, I'm putting k there. So I have 5 raised to power 2 multiplied by k minus 6k plus 8. So here, I'm assuming that it is true. So I'll now say 9m. So because we are assuming that n is equal to k is true, so we want to assume that it is divisible by 9. So if you multiply any number by 9, that means the answer gotten will be what? Divisible by 9. So let's keep this one. Now from here, you can now say that let's make 5 raised to power 2k the subject of the formula. So it will be equal to 9m plus 6k then minus 8. So let's call this one equation 1. So after assumption, we can now prove. We want to prove that the next number after k, is it going to be true as well? So prove that n is equal to k plus 1 is true. So to do that, anywhere I see n from this expression, 5 raised to power 2n minus 6n plus 8, I'm going to put k plus 1 there. So I have 5 raised to power 2 multiplied by k plus 1, that is anywhere I see n, I'm putting k plus 1, minus 6 multiplied by k plus 1, then plus 8. So let's simplify. So I have 5 raised to power 2 multiplied by k, 2k, 2 multiplied by plus 1 plus 2, then minus 6k, then minus 6 plus 8. So recall, if you have a raised to power m plus n, according to law of indices, it will be a raised to power m multiplied by a raised to power n. So the same thing is applicable to 5 raised to power 2k plus 2, which will be 5 raised to the power 2k multiplied by 5 raised to the power 2. So let's put that here. So I have 5 raised to power 2k multiplied by 5 raised to power 2 minus 6k minus 6 plus 8. So from here I have 25, that is 5 raised to power 2, that is 25, then multiply by 5 raised to power 2k minus 6k, then minus 6 plus 8, that is plus 2. So anywhere I see 5 raised to power 2k from equation 1, I'll put 5m plus 6k minus 8. So I have 25 into brackets 9m plus 6k minus 8 minus 6k plus 2. So let's multiply. I have 29 multiplied by 9m, that is 225m, plus 25 multiplied by 6. 25 multiplied by 6, that is 150k, minus 8 multiplied by 25, that is 200. Multiplied by 8, that is 200, minus 200, then minus 6k plus 2. So let's collect like terms. I have 225m, then plus 150k minus 6k. 150 minus 6, that is 144k. That is plus 150k minus 6k. So I have minus 200 plus 2. That will be what? Minus 198. So from here, are they all divisible by 9? We can see that they are all multiples of 9. So let's factorize 9 out. So 9 into brackets. How many 9 can I get from 225? That is 25. So I have 25m plus 144 divided by 9. 144 divided by 9 is 16. So I have 16k. Then minus 198 divided by 9, that is 22, minus 22. So, and I told you that if you use 9 to multiply any number, if you represent 25m plus 16k minus 29 by any alphabet, that means it will be, let's say we represent by m or p, so this will be 9p. So if we multiply 9 by any number, that means that number is divisible by 9. So we can now say that since this happened, since we can factorize 9 out, so hence if n is equal to k is true, then n is equal to k plus 1 is true for 5 raised to power 2n minus 6n plus 8 to be divisible by 9 for any positive integer. So you can just say it in the way you understand it. So that is how to go about that. Till I see you again. Thank you. Bye bye.